So in this section, we're going to talk about differentials. So if x changes from x to delta x, okay, so if I take this function f, I plug in x, I get an output of f of x. And if we change from x to x plus delta x, this is a difference of delta x here. I plug in, I get f of x plus delta x. Okay, so I have a secant line that runs through the two here. So delta, then what does that tell me? Delta y, which is the distance between f of x and f of x plus delta x. Okay, so divided by delta x, all right? So we're changing from x to delta x. This distance here is delta x. What is this equal to? Well, it's the slope of the secant line here. And this point right here is based off of x and f of x. And this point right here is based off of x plus delta x, comma, f of x plus delta x. Okay? So to find slope, I do y2 minus y1 over x2 minus x1. So the change in y divided by the change in x. Okay? If I simplify the denominator, x minus x cancels, and all I have left is delta x in the denominator. All right? Now, the definition of 4.4.1, differentials of x and y. Let f be a differentiable function. Then we define the differential of x, denoted dx, is any non-zero real number, usually taken to be a small number. The differential of y is denoted dy. This is equal to f prime of x times dx. So if you notice the differential, this is a little bit of a magic math here. Dy over dx equals the derivative of f, where y equals f of x, right? So technically, we're not doing this, but we're kind of magically moving the differential dx over to the other side where that dy stays there, okay? So you can think of it that way for now. When you talk about differential equations, you'll go more into detail into this, okay? Differential notation here. Let y equal f of x be a differentiable function. Then let f delta x represent a small non-zero change in x value, and dx represent a small non-zero change in the x value. Okay, i.e. delta x equals dx. Then I'm going to let delta y be the change in y values as x changes by delta x. Hence, delta y is equal to f of x plus delta x minus f of x. Okay? And so I'm going to let delta y equal the derivative of f of x times delta x, the differential of x, dx, which by equation 4.3 is an approximation of the change in y values as x changes by delta x. So dy is approximately delta x.